Model for attention. Attention mechanism is one of the recent advancements in deep learning, especially for natural language processing tasks like machine translation, image captioning, dialogue generation, and so on. It is a mechanism that is developed to increase the performance of encoder-decoder sequence-to-sequence recursive neural network model. Attention is proposed as a solution to the limitations encountered in the encoder-decoder model, which encodes the input sequence to one fixed length vector from which to decode the output at each time step. This issue is believed to be a problem when decoding long sequences because it makes difficult for the neural network to cope with long sentences, especially those that are longer than the sentences in the training corpus. Attention is proposed to be a method of align and translate. In attention, when the model is trying to predict the next word, it searches for a set of positions in a source sentence where where the most relevant information is concentrated. The model then predicts next word based on context vectors associated with these source positions and all the previous generated target words. Instead of encoding the input sentences into a single fixed context vector, the attention model develops a context vector that is filtered specifically for each output in each of the time steps. The attention model removes the bottleneck of encoder-decoder model. It pays selective attention to relevant parts of the input, utilizes all the intermediate states while decoding, and does the alignment while translating. Now we have the German sentence Morgen fliege ich nach Kanada zur Konferenz, which when paying selective attention first was introduced in image recognition, where in this image it is recognized that a woman is throwing a frisbee in the park. The model which we saw in encoder decoder, where four encoders and four decoders were present, and the inputs x1, x2, x3, and x4 were given respectively to the four encoders, and y1, y2, y3, y4 was the output generated from the four decoders. This decoding was done using only the final state. In attention score is generated from LSTM. LSTM is stands for long short-term memory, which is a network and a type of a recurrent neural network capable of learning order dependencies in sequence prediction problems. That is making sure that the ordering of the sentence remains intact. This is a behavior required in complex problem domains such as machine translation, speech recognition, and so on. In machine translation, we had seen in the previous video lecture that the sentence in a particular language may not remain in the same order while being translated into another language. The LSTM takes care of this issue. The Here we can see that the English sentence "I am a student" is given to in LSTM model and the same sentence in French is given as the input to the LSTM model, their respective dot products, that is the dot product between the output of LSTM from the French and the LSTM from that of the English model, is then calculated to find the attention score. Attention captures the alignment. That is, it aligns the respective words in a particular language with the words in the translated language. Pace selective attention is used to words when we need to translate. Weighted sum is computed for all the hidden states. Attention uses weights while decoding. Attention also takes care of the alignment. These are some important points regarding attention. We now have transformers. The transformer in NLP is a novel architecture that aims to solve sequence to sequence tasks while handling long range dependencies with ease. Can we get rid of recursive neural network completely with the use of transformers? Recursive neural networks are too sequential. Parallelization is not possible in these since these intermediate contexts are generated sequentially. Now, in transformers, the LSTM model can be avoided. The LSTM model can be avoided by applying attention to the sentence itself, that is self attention. There are three kinds of attention: within the encoder, encoder decoder, and within the decoder. Using self attention, the attention for each of the word is calculated with respect to its dependency on the other words. Here, for example, a particular mathematical equation for is used to calculate the dependency of a particular word on several other words. Remember that encoder creates an input representation. Transformers create a rich representation that captures the interdependencies. This rich representation captures the relationship between words compared to simple word embeddings. This rich representation is called self-attention. Self-attention mechanism directly models relationships between all words in a sentence regardless of the respective position. Self-attention allows connections between words within a sentence. Example: I arrived at the bank after crossing the river. Now, if we take another example, as last week, shareholders took their money and ran. We have the action took their money, and when did it happen? That would be last week. Who took away their money? The shareholders. And what is the subsequent action after taking the money? Is running. Transformers use self-attention instead of recursive neural networks. CNN, which uses computational, could not be possible there. But in transformation is a possibility. Using self-attention in the encoder and decoder model, in the first encoder model, after self-attention, the feed-forward network is where the message goes. In the decoder model, after self-attention, the encoder-decoder attention takes place, and then the feed-forward network is given. This is an example of translation where the French phrase "Je suis étudiant," which means "I am a student," is translated into English, where "I am a student" comes into picture or comes as the output. The encoder model is seen in the left portion of the image, where the input layer is followed by the self-attention, which is followed by feed-forward network, and then it's translated to the encoder output. This encoder output is given to the decoder model, where which is the input layer, and then it's self-attention that is masked, and another layer of attention is given to it, and then feed-forward network, which produces the output of the decoder. There are two types of attention: source target attention and self-attention. What is the difference between these two? It depends on where the query comes from. If the query comes from the encoder, it is self-attention. And if the query comes from the decoder, it's source to target attention. Thank you.